Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss the solution of our next question, that is the copy set bits in a range. So in this question we are given two numbers A and B. We are given another two numbers, that is left and right. So this left and right are representing a range, right? So you have to set bits in B which are set in A lying in the above mentioned range. So in the given range, we have to make the bits set in B which are set in A, right? So let's understand this problem by taking an example. So let's suppose A is given as 1 0 1 0 1 1 1 0 1 0, right? So B is given as 0 1 0 1 0 0 1 0 1 0, right? So let's suppose left is given as this, right is given as this, right? So we have to do, so this is our range, right? So we have to update the bits of B in this range only, rest all bits remain same in B. So this should be our B, we have to update our B, so this should be our answer, right? So we have to we have to do what? You have to set bits in B which are set in A. So in the given range, the bits which are set in B, we have to set that bits in B also, right? For example, this bit is not set in A, so we have to do nothing with this bit. Now this bit is set in A, so we have to make this bit set in B also. Now this is already a set bit, so this will be copied. Now this bit is set in A, so we have to make this bit set in B also, so set this bit. Now this bit is also set in A, so we have to set this bit in B also, so set this bit in B. Now this bit is not set in A, so we have to do nothing with this bit. So we have to do what? In the given range, the bits which are set in A, make those bits set in B also. The bits which are not set in A, we have to do nothing with those bits, right? So I hope the question is clear to you. Let's take one more example, then we will discuss the solution, right? For example, A's are 1 0 1 1 0 0 1 0 1 1 0 1, right? B's are 0 1 0 0 1 0 1 0 1, let's take 0 here, 0 1 0 0 1 1, right? So let's suppose left is given as this bit and right is given as this bit. So we have to update our B and we have to update the bits in the given range only, right? So we have to do nothing with these bits, right? So these bits will be copied, right? So now these bits which are set in A, make those bits set in B also. So this bit is set in A, so make this bit as a set bit in B also. This bit is set in A, make set bit in B also. This is not set in A, so we have to do nothing with this bit, right? So copy this bit. Now this bit is set in A, so set this bit in B also. This bit is not set in A, so nothing to do with this bit. Now this bit is not set in A, nothing to do with this bit. These bits are copied, right? So this is also copied. Now this bit is set in A, so make this bit set in B also. So the bits which are set in A, those bits are also set in B now, right? So the bits which are set in A are now set in B also, right? So right, so this is our answer, right? So we are doing what? This in the given range, the bits which are set in A, make those bits set in B also. For example, these bits are set in B now, right? The bits which are not set in A, copy these bits as it is. So copy these bits as it is, right? So I hope the question is now clear to you. Now let's discuss the solution of it, right? So we can see that we have to do work with the bits in the given range only. So we have to develop a mask in which only these bits are present. That is, we want a mask like this. Rest all bits are 0, only the bits in the given range are the required bits, right? So we want this kind of mask, right? So if we got this kind of mask, we will do what, that we will perform a OR operation of this mask with B, right? So this is our B, 0 0 1 0 0 1 1. So perform the OR operation. So OR is what? In OR operation, 1 is powerful, so it will make any bit to 1, right? So if 1 is present, it will make the bit to 1, otherwise the bit will be 0, right? So we will get our desired answer, right? So now our task is to get this mask, right, in which the bits in a given range are only the required bits, rest all bits are zeros, right? So now our task is to get this mask, right? So let's now how can we get this mask? So we will take a binary 1, right? So now in order to get this mask, we will develop another mask that is something like this, in which all the bits which are in a given range are set to 1, right? So we firstly we get this mask, then we will go to this mask, right? So we have to develop this mask. So we will take a binary 1, right? So our binary 1 is like this, right? Next we will do what, that we will right shift this mask by how many bits? By the bits required in a given range, right? So bits in given range are 1 2 3 4 5 6 7. So right shift this mask by 7, right? So we will get 2 3 4 5 6 7, right? So right shift this mask by 7, 2 3 4 5 6, here 1 will come. So we will get this as our output. Next mask, next subtract 1 from the resultant mask, right? So subtracting 1, we will get 3 4 5 6 7, right? So 1 2 3 4 5 6 7, right? So subtract 1 from this mask. Now we are getting all the set bits of this range. So the set bits are 1 2 3 4 5 6 7. So we are getting 1 2 3 4 5 6 7. Now our task is to again we want these two zeros, right? So we will again right shift this mask by 2. Now this 2 is what, the left value, right? So again right shift this mask minus 1 by 2, right? So we will get 4 5 6 7 and this. So we will get this, the first mask. Now in order to get this mask, that is our desired mask, we will do what, that we will perform the AND operation of this mask with our A, right? So our A is 1 0 1 1 0 0 1 0 1 1 0 1, right? 1 0 1 1 0 0 1 0 1 0 1. So let's remove 1 from here, right? So perform AND operation of this mask with A. So in AND operation, 0 is powerful. So if we perform an AND operation of any bit with 0, so it will convert the answer to 0, and 1 is less powerful. If we perform AND operation of any bit with 1, we'll get the same bit, right? So we will perform the AND operation of this mask with A. So the zeros will convert all the bits to zeros, and the 1 will remain the same bit, right? So right, so next is, now we are getting this mask, right? So we are getting this mask. Now we have to do what, we have to perform the OR operation of this mask with B, right? So perform the OR operation of this mask with B, right? So our B is what, 0 1 0 0 1 0 0 1 0 1 1, right? So perform the OR operation. Now in OR operation, 1 is more powerful, right? So if we perform OR operation of any bit with 1, the answer will be converted to 1, and 0 is less powerful. So if we convert the OR operation of any bit with 0, so we'll get the same bit. So all these 0 will help us to get the same bits in B, and all these ones will set the bits which are not set in B to 1, right? Because in OR operation 1 is more powerful, right? So all these bits are set to 1, and 0 will remain the same. Why? Because 0 is less powerful in OR operation, right? So we are doing what? Let's take a small example. It is 1 0 0 1 0 1. Our B is 1 0 1 1 0 0 1, right? So let's suppose this is our left, this is our right, right? So first of all, what we were doing, right shift the mask, that is right shift 1 by how many bits? The given range. So given range is 1 2 3 4, so right shift 1 by 4. So our 1 is, this, so right shift it by 4. So after this we get this, right? Next is subtract 1 from this mask. So after subtracting 1 we will get, right? Next step is again right shift it by left value, right? So left is left bit is 1 only, so right shift this by 1. So right shift this by 1. So we will get, right? Next is, this is our mask. So perform the AND operation of this mask with A. So our A is 1 0 0 1 0 1. So perform the AND operation. Now why we are performing AND operation? Because in AND 0 is more powerful, so it will convert the bits which are not in our range to 0, right? So it will be converted to 0, and rest are all, right? So we are able to get the bits which are in the given range, right? Rest all bits are set to 0. Now simply perform the OR operation of this mask with B. So our B is 1 0 1 0 0 1 1 0 1 0 0 1. So why are we performing OR operation? Because in OR operation 1 is more powerful. So we have to do what? That we have to set the bits which are set in A. So set those bits in B also. So rest all bits will remain the same. Why? Because 0 is less powerful. So this will convert these bits which are set in A set to B also. The bits which are already set in B, those will remain the same, right? So this bit is not set in B, so this bit, this mask will convert this bit to set, right? So we'll get our desired answer, right? So this is the approach. So let's try to code this. First of all, we are doing what? That we are taking a mask, that is the binary 1. Next, we are performing the right shift on the mask by the given range. Right shift. Now the range is what? Since we are including the right and the left part also, so our range will be right minus left plus 1. For example, this is our first, second, third, fourth, fifth and sixth bit. So if I'll perform only right minus left to get the range, this will give me 5 minus 2, that is 3. But the number of bits are 4. So we have to add 1 here, because we are including these range also, right? So our range is what? Right minus left plus 1, right? Next is subtract 1 from this mask. So it will perform the subtract operation. Next is again right shift it by L value. Now since the indexing is start from 1, so we have to keep it L minus 1, because L is 2. We want only these left bits, so we have to perform L minus 1 operation. So our mask will be, right shift the mask by left minus 1, right? Now after that we are doing what, that perform the AND operation of mask with A, right? So our desired mask will be mask and A. Next we are performing the OR operation of the mask with B, right? So we have to update our B. So our B will be perform the OR operation of the B with mask, OR, right? So we have to print the updated value of B, right? So this is our code. Let's try to run this. One semicolon is missed here. So we are getting the correct output. Let's try to submit it. So our code is passing all the test cases, right? So what we are doing, we are developing the mask in which we only want the bits which are in the given range only. So we want only that bits in A which are in given range. Next we are performing OR operation of this mask with B because we want to make this set bits in A set in B also, right? So we are performing the OR operation. Why? Because in OR 1 is more powerful, right? In order to get this mask, we are developing one more mask. So we are performing these operations. Right shift it by the given range, subtract 1 from it. Next again right shift it by the L value, the number of bits left. Next perform the AND operation of this mask with A to get our desired mask. Now in AND operation 0 is more powerful, right? That's why we are performing AND here, right? So next we are getting the desired mask, perform the OR operation of that with B, right? So I hope you understand the solution of this problem. So thank you for watching this video.